Okay, so we've covered how to simplify rational expressions. Rational expressions, of course, meaning that we have a fraction. Okay, that's what a rational expression is. It can be written as a fraction. So once we've simplified, now we're going to look at multiplying and dividing rational expressions. Okay, one of our rules when we looked at fractions is that if I have a over b times c over d, same thing as a times c divided by b times d. Okay, so you're just multiplying across the numerator, multiplying across the denominator. We're going to be looking at the same thing here. Only one thing we do want to do with these things is we want to go ahead and simplify them as much as we can. It'll save us a lot of heartache of having to multiply very large numbers. So we're going to look at doing that. I'm going to start with an easier one here that I can actually write out and show you. So for instance, if I were to write this out longhand, remember we did this in section 7.1, so 9 would break into 3 and 3, 18 would break into 9 and 2, which breaks into 3 and 3. So I can write the top out as 3 times 1, 2, 3 x's, 2 y's, all divided by, so I've got a 3, a 3, a 2, that's my 18. I've got 1x, and I've got 5 y's. 1, 2, 3, 4, 5. Let's extend that fraction bar. All of that is times y to the third. So I've got 3 y's. 1, 2, 3 y's. We're just going to put that over 1 because I don't have anything on the bottom there. So if I wanted to look at it that way, it's just a matter of going through and canceling out everything that matches, even across this little thing. Because if you think about the fact that a over b times c over d is a times c over b times d, well, these 3 little y's are just going to come and join these. And in the end, I'm going to end up canceling them anyway. So we're going to go through and cancel out all of our pairs. There's my 3's. I've got a set of x's that can go. I've got 2 y's that can go there. But I also have these y's are on top, and these y's are on bottom. So there's 3 there. So in the end, I end up with that negative that's still out front. I've got 2 x's left on top. I've got a 2 left on bottom. So negative x squared over 2 would be my answer. So what would that look like if I was doing it without having to write it out longhand? Okay, well, 9 goes into 18 twice, so I would get 1 over 2, which is where the 2 comes from. And then I would go through and I would just subtract. Remember, you could subtract the smallest exponent from the largest. So this would subtract. Have x to the first, so I would get rid of the smallest, subtract it from the largest. That's how you get x squared in the top. Okay, here my smallest is y squared. I would subtract it from the bottom. I'd get 5 minus 2 is y to the third. But then I have a y to the third and a y to the third. So those also canceled, giving me negative x squared over 2. So that's what you're looking at. Keep in mind when we want to simplify things, we have to factor them out completely, just like we did for simplifying. So for instance, looking here, okay, which I'm going to do over here, x squared plus x, I have a GCF of x, so that's going to come out, and I'm left with x plus 1 in its place. Okay, that's this piece right here factored. And that is over 3x times, can't do anything with the 6 yet, so we'll leave it. And I've got 5x plus 5, so I have a GCF of 5x plus 1. Now from here, I can either multiply it all together or I can go ahead and just start reducing. The biggest thing about reducing, when I simplify these, is that you can only reduce numerators with denominators. Only numerators with denominators. So I can't cross out 2 things on top or 2 things on bottom. I have to cross out things on top with things on bottom. So things in the numerator cancel with things in the denominator only. So here we go. We've got an x plus 1 on top and bottom. Those are gone. Okay, it doesn't matter which fraction that they're in, because you got to imagine that I could have written this out. X plus 1 times 6 all over 3x times 5 times x plus 1. Okay, that's what this rule right here means. Okay, that's what this rule up here means, is I could have just multiplied out the top and then gone through and canceled x plus 1s. So our x's can go. Okay, and then our 3's can reduce. I've got a 3 here, and a 3 goes into 3 once and into 6 twice, and that's it. 2 and 5 don't go together, so our final answer here would be, again, I'm just working this out two different ways. One, I've multiplied it together right here. Here's where I keep it separate, and as long as I'm doing numerator to denominator, I'm going to get the same answer either way. So on top, I still have a 2 left. On bottom, all I have is a 5, so I just have 2/5 as my answer. Okay, so you don't actually have to take this step where you multiply it all together. You don't want to multiply them all out. It's going to make it a lot more difficult for you, because then you're going to have to turn around and factor it all back out. Okay, don't multiply it just to turn around and divide it all. Okay, so taking a look at another one. So same sort of idea. Let's go ahead and break these things down. Starting with this one right here, I have a GCF of 3, which leaves x plus 1. Okay, so that goes here. Over here, I've got a GCF of 5 and an x. Okay, there's an x in both, so I'm going to take a 5x out. I'm left with 1 minus the x. 1 minus an x. We might have to change that later. We'll take a look. Okay, here, target product, target sum. I'm going to do this off to the side. Target product is -6. 2 times -3. Target sum is +1. Target sum is +1. So I've got +3 and -2 would multiply to -6, but add to +1. So I would get 2x squared plus 3x minus 2x minus 3. To factor that by grouping, I've got an x, 2x plus 3. Take a -1 out, I've got 2x plus 3. So I end up here with an x minus 1, 2x plus 3. Okay, x minus 1, we'll talk about this in just a second because there's something special here, times 2x plus 3. Okay, that would be the numerator. Now the denominator, that is the, let's go ahead and separate our work. Those are perfect squares. It's a binomial, and they're perfect squares, so I'm going to square root both of them. So on bottom, I will get 2x plus 3 and 2x minus 3. Okay, factoring the difference of squares. 2x plus 3, you just square root both of them, and then you'll have a plus and a minus version of each. Now, before I move on, very quickly, notice here I've got 1 minus x. Here I've got x minus 1. Okay, so if I were to take a negative out of this and bring it up here, that changes both of their signs. So I get -1 and positive x. Okay, that changes both of their signs. I take the negative out. I've got a -1 and a positive x left inside. Well, now x minus 1, now those things can cancel. We want things to cancel as much as possible. Okay, so 2x plus 3, I got 1 on top and bottom. Those can both cancel. 3 and 5 don't reduce. Now I can't do this x right here with this x here. I want you to be careful here. This x is connected with a 1. Okay, we put parentheses around it to say this thing right here is grouped together. Okay, this x is out here all alone, so I can only cancel this out with another x plus 1. And x all by itself does not work. Okay, so when you look at it, I don't have anything else left to cancel, so you just write your final answer. On top, I've got 3x plus 1 over, and I'm going to pull this negative all the way out front just because it's more proper, 5x times 2x minus 3. Okay, notice that it becomes multiplication. Once what we were doing was multiplying. So I get 5x times 2x minus 3 on the bottom. You don't have to work that out. You can leave it just like that. If you left your negative here, that would be correct as well. It's kind of on you on how you want to take care of that. Okay, so I would suggest that you hit the pause button here for a second. Okay, go ahead and see if you can do the your turn that's up here. And then when you get your answer, or if you find yourself getting stuck, come back and see how this works out. Okay, I'm going to go ahead and continue on. So I have to factor first. That's going to be the biggest part of all of this, is you're going to factor things. You need to factor completely. That's why it's so essential that you know how to factor. So if you're still struggling, go back, watch the videos, come to tutoring, whatever you need to do. Make sure you learn how to factor. You cannot leave Algebra 3 without being able to factor. It's a must. Okay, so let's take a look. So right here I've got x squared minus 25. It's a binomial, okay, two terms, and they're both perfect squares. So we're going to square root them both. Okay, we're going to square root them both. Let's see, I'm trying to figure out where I want to do this at. Square root of x squared is x, and the square root of 25 is 5. Okay, so I get x plus 5 and an x minus 5. Okay, x plus 5 and an x minus 5. Square root both, you get a plus and a minus. Okay, on the bottom, there's our first one. Now on the bottom, we got to factor that also. Target product is negative 10. Target sum is negative 3. So I need two numbers that multiply to negative 10 but add to negative 3. I believe that's going to be negative 5 and positive 2. Okay, add to negative 3, multiply to negative 10. Careful with your signs. I want a negative 3, so the negative has to be on the 5. Okay, so this is a coefficient of 1 in front of x squared, which means I am allowed to shortcut. So I get x minus 5 and x plus 2 as my factors, times, so here I've got the x plus 2 over x. Nothing to factor there, no GCFs or anything. Now it's just a matter of starting to simplify. Okay, I've got an x plus 2 on top and bottom. Those are gone. I've got an x minus 5 on top and bottom. Those are gone. I'm left with an x plus 5 over x. Okay, again, I can't just do these x's here. Remember, anytime we have a plus or a minus in between things, okay, that means these things are bound, basically bound for life unless I factor them out. Okay, I've got an x plus 5, so the only way I can reduce if there was an x in all three of them. Since I don't have an x in all three of them, I can't do anything else. That is just my answer, x plus 5 divided by x. That's basically it for the multiplication. The hardest part is going to be the factoring. Okay, the factoring is really going to be the most difficult part. You just have to learn how to factor these things out properly, and then you're just looking for matches. Okay, so then after that, it's just a matter of simplifying. Now, dividing rational expressions. These things are going to look very ugly, okay, but they are not bad at all, because basically you're going to end up multiplying again. We did this when we talked about fractions. If I have a fraction divided by a fraction, then you keep it, change it, flip it, or keep it, flip it, change it. A lot of people like to think of it as KFC. Okay, I know that kind of makes you hungry for lunch, but KFC, keep it, flip it, change it. Okay, you keep the first one the same. A over B is just going to stay the same. You flip that second fraction, so here we had A over B divided by C over D becomes D over C, and you change it to multiplication. Keep it, flip it, change it. Keep the first, flip the second, change it to multiplication. Okay, and then it's just a matter of multiplying. A times D on top, B times C on bottom. Now I want to show you the way that tends to throw people off. A lot of people are okay with this particular format, but then when they see this format, A over B over C over D. Okay, suddenly we've forgotten all rules of mathematics once we get to this point. But please keep in mind that this means the same thing. A fraction bar is nothing more than division. So this says A over B divided by C over D. So this right here is the exact same thing as A over B divided by C over D. So I would still keep it, flip it, change it. So from there you would get A over B, okay, flip the second, which is D over C, and change it to multiplication. So that would happen here as well. I would just take the C over D, okay, flip it over to D over C, and change it to multiplication. So please keep in mind, don't let this scare you. I know they look really ugly when they look like this. A divided by B divided by C divided by D. I get it. It looks ugly, but fraction divided by fraction. That's all you're really looking at. So when you do this, same sort of thing. Okay, you're going to keep it, flip it, change it. So keep the first the same. 3x cubed, y to the 7th, all over 40. Flip the second one, you get y squared over 4x cubed, and change it to multiplication. Now it's the exact same stuff that we did in the top, and you just need to go through and simplify everything you possibly can. Okay, remember, you can't simplify the bottom, so don't reduce 40 and 4. That doesn't work. It has to be numerator with denominator. For instance, I've got x to the third power here on top and bottom. Those can both go. 3 does not go into 40. 3 does not go into 4. So those aren't going to work at the moment. So we're going to go ahead and multiply this. So we get 3y to the, remember when I multiply bases, I add their exponents. You still have to know your exponential properties. So y to the 7th, hold on, screen froze. So y to the 7th times y to the 2nd is y to the 9th. We add the exponents. Do the same for the bottom. 40 times 4 is 160. Okay, when you get here, you always want to double check and see if this will actually reduce. 3 does not go into 160, so that is your final answer. Okay, so same sort of thing. Whenever I'm doing the division, I want to go ahead and do the keep it, flip it, change it first. You must do keep it, flip it, change it before you reduce. Okay, so KFC before you reduce. Okay, always KFC before you reduce. Keep it, flip it, change it, then start breaking things down. So, let's go ahead, keep the first same. Flip the second one. 1 minus x, 3x squared plus x. Change it to multiplication. Now let's go ahead and reduce, factor, all of the above. So starting with the factoring, I got a GCF of 2 here, so I get 3x plus 1. Okay, here I've got 1 minus x. I'm going to go ahead and take out a negative 1 so that I have x plus 1. Okay, sorry, x minus 1. Goodness. Okay, you take your negative 1 out. That changes both of those signs, so I get a positive x and a negative 1. I went ahead and switched the order. On bottom here, this is a difference of perfect squares. Square root of x squared is x. Square root of 1 is just 1. So I get x plus 1, x minus 1. Here I've got a GCF of x. So I'm going to take the x out front, and I'm left with 3x plus 1 inside. 3x plus 1 inside. Now that I've got it all factored, just start canceling out things that match. I've got x minus 1 on top and bottom, 3x plus 1 on top and bottom. I've got a 2 and a negative 1, which doesn't cancel with either one of those things. So final answer here, 2 times negative 1 is negative 2 on top. And I've got x times x plus 1 on bottom. Now it doesn't matter if you do x plus 1 times x or x times x plus 1. It's more proper to put the x in front, but either way is going to give you the correct answer. That would be your final answer. Nothing else to simplify. So what do we do if there is no denominator? Same thing you do if it's a fraction with no denominator. We just put it over 1. Okay, anytime you're working with fractions and you don't have a denominator to work with, you just put it over 1. So we're going to do the same thing here. Here we go, keep it, flip it, change it. X squared minus 10x plus 21, all divided by x minus 7 times 1 over x minus 3. Okay, we just took this right here, we flipped it over, now it's 1 over x minus 3, change it to multiplication. Okay, I need to factor this little piece up here, target product, target sum. Target product is positive 21, target sum is negative 10. Okay, two numbers that multiply to positive 21 but add to negative 10 is going to be negative 7 and negative 3. Those would add to negative 10, multiply to positive 21. I do have a coefficient of 1 in front of x squared, so I can shortcut. X minus 7, x minus 3, that's over x minus 7 times 1 over x minus 3. Okay, cancel everything that matches. X minus 7's go, x minus 3's go. Okay, always keep in mind that really what we're doing here is dividing. So if everything goes, you have to leave a 1 in its place. Okay, so we end up with 1 over 1, which is just going to be 1. Okay, we'll end up with a 1 up here. 1 times 1 is 1. We end up with a 1 times 1 on bottom, which is just 1, so 1 over 1 is 1. That is possible. Okay? Again, I would go ahead and hit the pause button, see if you can get the correct answer for this before you watch me do it. Okay? see if you can get the correct answer. I'm going to go ahead and do it. Keep it, flip it, change it, start there. X plus 3 over x squared minus 9 times 5x over x squared minus 8x plus 15. Okay, we flip this over, 5x goes on top. It does matter which one you flip. You have to keep the first the same and flip the second one. You can't switch the order. I can't flip the first. That doesn't work. You have to flip the second term. Okay, from there we factor. This one right here, x plus 3, stays the same. This is a difference of perfect squares. Square root of 9 is 3, so I get x plus 3, x minus 3, times the top. There's nothing there to factor on bottom. Target product, target sum. Target product, target sum. Target product is 15. Target sum is negative 8. Two numbers that multiply to 15 but add to negative 8 would be negative 5 and negative 3. Coefficient of 1 in front of x squared, so we're going to shortcut it. X minus 5, x minus 3. Okay, just start canceling everything that you can. I've got an x plus 3 on top and bottom. Those are going to cancel. Now here again, be very careful. X minus 3 and x minus 3, but they're both in the denominator. We can't do it if they're both in the denominator. Nothing else here is going to cancel. So our final answer, I've got a 5x on top. I've got an x minus 3, an x minus 3, and an x minus 5 all left on bottom. Now don't take the time to multiply that all out. You don't have to worry about that. Just leave them as they are. If you want to write x minus 3 squared, that's perfectly fine. There's nothing wrong with that. That would be correct as well. And that is the end of multiplying and dividing rational expressions.